Now, you're on note sheets, page 16, and here we go. Y varies directly as x. It says write an equation for the following. So, part A, y varies directly as x. Your direct variation equation is y equals kx. When things vary directly, we express it y equals kx. All right? Now, what does vary directly mean? Well, here's an example. Marissa and I pull up to the gas station, at exactly the same time. She puts 5 gallons of gas in her car. I put 8 gallons of gas in my car. Who pays more?
You.
I do. Why do I pay more?
You got more.
I got more gas. That's direct variation. If you buy more, you pay more. That's direct variation. If you buy less, you pay less. They both move in the same direction. The number of gallons and the money you pay either get bigger together or they get smaller together. That's direct variation. The equation for that is right here. At the gas station, it would be y equals 2.29x. If x is the number of gallons, the amount of money you pay would be 229 times the number of gallons, right? That's direct variation. Now let's skip down and look at C, because C is another direct variation. P varies directly as the square of Q. All you're doing is writing the equation. P varies directly as the square of Q. When things vary directly, you have one variable on this side and K times the other variable over here. Look at E. What's E going to say? Height varies directly as weight. So H equals KW. Height varies directly as weight. When things vary directly, it's one variable equals K times the other variable. Now, when they vary inversely, like problem B, these are the only 2 variations you're responsible for. Direct variation and now inverse. When things vary inversely, one variable is K divided by the other variable. So D says M varies inversely as the sum of A and B. Remember, with inverse, one variable equals K over the other one. So in this case, we have M, and then we have the sum of A and B. G. Rate is inversely proportional to distance. Now, inversely proportional is the same as varies inversely, okay? So rate is inversely proportional to distance. Remember, with inverse variation, one variable equals K over the other one. With direct variation, one variable equals K times the other one. Okay? Now, I skipped F. The words is proportional to, whoops, they're spelling right, is proportional to means direct variation, okay? So you just have to kind of be familiar with that language. When we say things are proportional, that means they vary directly. So the answer to F is exactly the same as the answer to A. It's two ways of saying exactly the same idea. Direct direct variation means one variable is k times the other one. Another word for direct variation is proportional. Inverse variation means one variable is k divided by the other variable. And if you see the word inverse in the problem, then that's the way you're going to set it up. Okay? Now, let's look at number 2 where it says solve the following, because now you're going to practice this a little bit. Look at 2a. Temperature is directly proportional to volume. Okay, so give me an equation for directly proportional. Temperature is directly proportional to volume. Does that equation make sense to you? Yes, because direct variation means one variable is k times the other one. All right, let's look at the second sentence. All right, so that's the first sentence. Now the second sentence. If the temperature is 70, the volume is 30. Guess what I'm going to do? Plug in. So if the temperature is 70, the volume is 30. Now what am I going to be able to figure out from that equation right up there? What k equals? What will k equal? 70 over 30, which is 7/3? Right? Now let's look at the third sentence. Find the temperature, remember this is our equation. Find the temperature if the volume is 20. So I put 20 in for my volume. What did I hear? That's 7/3. I already figured that out, didn't I? Now I know K. So temperature is going to be 7/3 times 20, which you can type in your calculator or just leave as 140 over 3. So the temperature is 140 over 3. B. Same thing. Here we go. 3-part question. 3 sentences. Volume varies inversely as pressure. What's the equation? Volume K over P. Volume varies inversely as pressure. Why is it K over P and not K times P? Because it's inverse. If the volume is 200, the pressure is 40. So into my equation, I put volume 200, pressure 40. So what does K equal? 8,000? And then the third sentence, find the pressure if the volume is 950. So volume, remember this is your equation, so the volume goes in here, 950, K is 8,000, and I want to find the pressure. So I'm using this same equation. I put in 950 for the volume, put in 8,000 for K, and now I have to find P. How do I do that?
Multiply by P.
Multiply by P. Very good. Thank you, Mason. And then,
Divide by 950.
so P equals 8,000 over 950, which we can read as a fraction, but we have to reduce it. Or you can type it in as a decimal, whatever is easiest for you. So as a fraction, it's 160 over 19. As a decimal, it's about 8.42. And I don't care which way you do it. Now, those problems seem overwhelming unless you go through a sentence at a time. If you slow down and go through one sentence at a time, then they're easy. They're super simple. All right, 2.2 done. Now you can do the 2.2 homework. Now we're ready to start 2.3, which is where the action is. Okay? So here we go at 2.3. Hang on to your hats, because we are going to sketch this polynomial without a calculator. Okay? Exciting. Here's what I want you to do first. I want you to plot on your graph, I want you to plot a point where x is -1. And notice how Mrs. Ford's labeling that point. That's how I want you to label it. Put a point at -1, put a point at 2, and put a point at 3. Now, as you're plotting those points, are you thinking, why is she putting points there? Are you figuring it out? Where did those points come from? The factors, right? So I put a point at -1, at 2, and at 3. And notice how I labeled them. That's how I want you to label them. Okay? Now, before we can do this, there are a couple of pieces of background information you need. Here's the first piece of background information. When you graph a cubic function, think of your BFFs. This is the shape of it, right? Oh, shoot. I gave it to Ellie because she said she was in your class.
All right, it's fine.
And she went to the rosary.
It's fine.
Okay.
Thank you.
She has it, though.
All right.
And she's in the gym now if you need to go get it from her.
Thank you.
Okay. So, this is what a cube looks like, right? Now, notice it starts down here and ends up here. Every odd-powered function, and when I say odd power, I mean x cubed, x to the first, x to the 7th. Anytime there's an odd power as your degree is odd, your graph is going to start down and end up. That's how odd powers behave. So how does that help me over here? Well, if I FOILed this out, which I'm never going to have you do, but if I did, if I had you FOIL all that out, then you would have x cubed. Agreed? I'd have a bunch of other stuff too, but you'd have x cubed. Now, that means I'm going to start down here. My graph starts down here. Every one of these points is connected by a smooth flowing curve. So I come up, I got to connect to this one, I got to connect to that one, and I got to shoot up into space. That is the graph of that polynomial function. Now, you might be asking yourself, how high up do I go, Mrs. Ford? I don't know. That's a calculus problem. We're not worried about it. I know I go up, but at some point I have to turn around. Why? Because I have to connect to this dot. And I go right through. At some point I have to turn around because I have to connect to this dot. I don't care how high and low you go. That's not important to me. You're doing this general shape. Oh my gosh, that is so easy. See if you can do B all by yourself. It's exactly the same kind of problem. See if you can do B by yourself. Is it another cube? Is B another cube, people?
Yes.
Yes, which means it's going to have that shape. Marissa, the dots are going to be in a different spot, but it's going to have that shape. So where are we putting our dots? You're supposed to be doing this on your own. Where are you putting your dots?
Negative 4, 0.
At negative 4, 0, and
Negative
you
3.
label it that way. 2, 0. Negative 3, 0. Everybody okay with the dots? Now it's a cube. We know how cubes are. They start down here. So here we go. Up it comes. That's it. That's all there is to it. Easy, right? Look at C because something different happens with problem C. What is different about it? It is still a cube, believe it or not. It's still a cube, but what's different about it? 2 of the factors are the same, right, Geechee? So that means when I put my dots, my points on here, there's only going to be 2. Because that one counts twice, but it's the same point. Would you agree? So I only have 2 points. Now, this is, remember I said there were 2 pieces of background information you needed. The first piece of background information is what we call the end behavior, and that is for a odd numbered degree, you start down and end up every time, if it's an odd numbered degree. Now, this is an odd numbered degree. It's a cube, so it's going to start down. When I say cube, I mean that's worth 2 x's, and there's the third x. There's 3 x's there. That's x cubed. It starts down. That's a fact. You're not going to change it. However, this dot happened twice, right? It's a square. So instead of just zipping right through like it normally does, it acts like a parabola and it bounces off. Now, it acts like a parabola because it's a squared, and aren't squareds parabolas? Yeah. So if you have a factor that's squared, you're going to bounce off of it. Now, it still has to come down and turn around and get to this one. Is it going to bounce off that one? No, because that one's not squared. So it's just going to zip right through that one. The plain factors just get zipped right through, right? The squared ones need to be bounced off. All right, let's try D. Uh-oh. Now I need to add to your background information. What's different about this one? It's even. The degree is even. When the degree is odd, we start down, end up every time. When the degree is even, it's like x squared. How does x squared behave? It starts up and ends up. If your power is even, you start up and end up. Okay? If your power is even, you start up and end up. So, my dots are at -3 and 2. But because if I FOIL this out, it's x to the 4th, that's even, it's going to start up here. Now, what's it going to do when it hits that dot that came from this factor? And it's going to come up and someplace turn around and come back down, right? What's it going to do when it hits that dot? It's going to bounce right back off. And there is a picture of this one. What do you think this does to my self-esteem, Harlan?
Come on, Diego. You taught it really well.
Yeah.
Diego.
All right, we're gonna do one more. We're gonna do E, and then it will be time to get gathered up to head to the rosary. So here we go. Problem E.
Do we bring our bags and stuff?
Problem E. Last one. Now, before you get started, you want to put your dots on here. So I have one at -1, I have one at 2, and I have one at -5. So I'm gonna put my dots on. Now, how many X's you got all together? What's the degree of this thing? 5. All right, that's an odd number. How do odd numbers behave? Start down and up. So start down. There we go. Starts down here. Now, when it hits this dot, you have two choices. It's either going to zip right through or it's going to bounce off. No, it doesn't bounce off. That came from here. It goes through. And then it comes down and gets this point. That one bounces because it came from here. Comes down to this one. That one bounces because it came from here. And there you go.
Wait, how do you know when to go up after that?
Because you should know that.
Because you go through there. It's not square. It's not square. If it went down, it would have to have a square.
Would you just stop?
If it bounces off, only if it has a square tower. All right, now listen. You, boys and girls, you, need to gather everything up, put it in your backpack, but the backpacks are staying in the room. We'll come back and pick them up.
Hello, Cathedral. This is Alexa. Happy birthday, Indiana.
All right, listen. Here is where we sit. In the gym. Section F. F as in Ford. Rows 4 and 5. Rows 4 and 5. We're sitting in from the bottom. From the bottom, rows 4 and 5. The ground floor, or I mean the bottom row is row 1.
Anybody got an extra?
And you must take off your college sweatshirts and leave them in the room.
What if we don't have a?
I don't have
Melodies on my shirt.
That's the rules, the new rules, man. You have to have a college shirt.
Actually, did you get the email?
Yeah, I don't make the rules. I don't make the emails. Don't give me the picture. Give me the picture. I don't make the rules.
I do.
Hey, Gucci, that's not a uniform sweatshirt.
That's not.
New rules, man.
All right, whoa, stop!
Hey.
Get back here right now. We're not going to this.
Serious? What? What is this?
Now, if you are not in uniform, I want you to come up here to the front of the room.
Yeah, let's go.
All right, and you're going to wear what I have.
There's no way. No.
Get up there, dude.
Okay, that's.
I'm not really comfortable with there.
Put your name on the board if you're taking one of my things.
I'm not comfortable with this.
Trey, you have a sweatshirt, dude. Somebody, yeah. Write your name on the board, list.
3X.
Put Jonathan on the board.
Jonathan.
3X has got to go Mason.
Oh, don't wear 1X.
Well, honey, you're the biggest person here, so you're going to wear that. Let's see what this is. This is, I don't know what that one is. This one was. This one.
I don't have full Jonathan. Doesn't matter. Still be.
This
Please know where they're clipping.
I don't know.
A black? Well, these clip in. I do live actually like
Here's a medium.
Thank you, Mr. Forsyth, for the video.
Okay, I gotta see for sure.
Oh, man.
Have we all got clothes now? Take this one off.
I don't want to forget it later.
Who has my stuff? Mason, John, Jake, and TJ, you're the only ones that have my stuff? Alright, we're section F, rows 4 and 5, let's go.
We should get egg bonus, honestly, because I came prepared.
I should get bonus.
Yeah, I'm just one more insurance.
You're in, what, okay. Does it say, is it cathedral? It doesn't say cathedral. Oh, yeah, it does, okay.